Lesson number 3, symmetry. Go down here. Oh, easier if we just jump down to interactive panel. Scroll across to number 3, symmetry of trig functions, and press play. Trace another unit circle by dragging the log around. In the last lesson, we learned how to get food with angles and side lengths in this first section. In this lesson, we'll learn how to apply that to the other 3 sections. First, let's improve our vocabulary so we can sound smarter. There's a proper name for these sections of the unit circle. Which of these options do you think it is? Everest, quadrant, quicksand, or quack? That's a mountain. That's just quicksand. That's the sound a duck makes, so I'm gonna try quadrant. Yep, nice. So we already learned about the first quadrant, which would be this one here. Now let's apply that to the other 3 quadrants. So these other 3 here. Let's focus on this angle here. Type it in. Okay, so 180 will be there. We go back a bit. Let's try like 160. Okay, maybe like 150. Nice. Although this angle puts us in the second quadrant, just like the last lesson, we can still use cos theta and sin theta to get the side lengths, okay? Work out cos 150 on your calculator and type in the result to 2 dp, or decimal places. Okay, cos 150, cos 150. Okay, so this is negative 0.87. As you can see, negative lengths on the unit circle mean instead of going this way, to the right, they go this way, so to the left, which is exactly the same as how positive x values go this way, so like that, and negative x values go this way, just like any graph. Now let's do sine 150 for the vertical length. Work it out on your calculator and type in the result to 2 dp, decimal places. So sine 150 is 0.5. Nice, this one was still positive, which makes sense because y values are positive in this direction, so going upwards, just like on every graph, and negative in this direction, going down. Okay. Let's have a closer look at the triangle we made. That angle 150 isn't actually the angle of this triangle. We can work it out by using the total angle from the start to this other side. Okay, so if we're trying to figure out this little angle in here, we can go from the start all the way to there. And that would be, well, that's a half of a circle, so that's 180. And minus the 150, which leaves us with, so 180 minus the 150, this missing bit here should be 30. So although we rotated 150 degrees from the start, the triangle we created actually has an angle of 30 degrees. So 30 degrees in there, okay. Now here's the interesting part. Let's compare that with an actual 30-degree rotation. Type it in, okay, 30 there. Now use cos theta to find the horizontal length for this rotation, all right. Cos 30, 0.87. And now sine theta, so sine of 30, 0.5, kind of the same. Alright, so let's compare the vertical length of each triangle. Are they the same? Yeah. That's right, they're both 0.5 long and they go straight up. What about the horizontal lengths? Well, they're both 0.87, I guess, so yeah. Okay, but one's positive and one's negative. Okay, so I guess maybe they're not the same then. Yeah, one's positive, one's negative, so they're not the same. But they are sort of similar, so let's just say they're sort of equal. Sort of, they're the same length, but one's positive, this one, and one's negative. Okay, so they're sort of the same. But the vertical lengths were the same length and the same direction, which is why they're exactly the same. Okay. This pattern continues in the other 2 quadrants, which we'll look at next. We're going to make another 30-degree triangle down here. Okay. Let's work out what main angle we need to make this triangle. So like how far do we have to rotate? So that part will be 180. How much further we need to go to make it all the way here, all right? Okay, so 180, and then an extra 30 would be 210. Okay. Now the lengths of this triangle should be the same as the other 30-degree triangles. All right. Use that to figure out the length of the horizontal side. So this guy right here. Well, that's going to be 0.87, but it goes to the left, so it should be the same as this one. So it should be negative 0.87. Nice. And the length of the vertical side? Well, these ones have vertical side lengths of 0.5, and it should be the same as them, because it's still a 30-degree triangle, so let's type in 0.5. Oh, but that would go up, whereas we want it to go down, so let's do negative 0.5. Cool. Awesome. This time the lengths went to the left and down, which is why they're both negative. Okay, so this one went left, which is negative, but then it went up, which is positive, so we had a mixture there. But this one, they're to the left, which is negative, and down, which is negative, so they're both negative. Okay. There's one more 30-degree triangle we can make, which would be down here. Let's work out what main angle we need to make this triangle. For this one, we can use the fact that a full rotation will be 360 degrees, all right? But then we could come back 30. So using that, try to find the angle. Okay, so 360, and then 30 less than that would be 330. Cool. Nice. Now the lengths of this triangle should be the same as the other ones. Okay. Use that to figure out the length of the horizontal side. Okay. All the horizontals have been 0.87s, but is it negative or positive? Okay, well it goes to the right, so it should be the same as this one here, which is 0.87. And the length of the vertical side, they've all been 0.5, but is it positive or negative? Well, positive would go up here, so if we did 0.5, yeah, that would go up there. So we should try negative 0.5. Ah, it goes down there, nice. Awesome, this time the lengths went to the right, positive, and down, negative. Cool. Once you get good at this, you can use the lengths from the first quadrant to easily work out lengths for the other three quadrants by making them positive or negative. So let's try to find all the lengths of the triangles similar to this one. Find this angle first. Okay. It's like a bit past halfway, maybe like a 50. Maybe like 60. Nice. Now use cos theta and sin theta to find the side length, starting with the horizontal. Okay, so cos of 60 is 0.5. And sine of 60 is 0.87. Huh. It's kind of the same numbers as the last one. Nice. Now let's work out what angle would create another 60-degree triangle in the second quadrant. Remember, for the second quadrant, we can think about getting to the halfway point, then going backwards, minusing the angle we want. So 180 degrees minus something. Okay. Using that, find this angle to create our second 60-degree triangle. Well, we want 60 to be in here, because that would create a 60-degree triangle. So 180, get to here and then come back 60, means we could rotate to 120. Let's try that. Yeah. Nice. And then we get our 60 in there. All right, now use cos theta and sin theta to find the side length, starting with the horizontal. So we could do that. We could also just use the 0.5 from here. So we should get 0.5 again. So a couple ways you can do it. You could go sine 60 again, cos 60 to get 0.5, which we kind of already knew. But then we know it needs to be negative. Another thing we could do is, what angle did we just use? We just used 120 to get to here. So we could do cos of 120, and that would give us negative 0.5. So either way it works. Probably the easiest way is just look at how we have a 60 degrees here, which gave us a 0.5 horizontal. Also 60 over here, but this time the 0.5 goes to the left, so it would be negative 0.5. So doing the same with the sine, the vertical should be 0.87, and then does it go up or down for this actual triangle here? Well, it still goes up, so 0.87. We don't even need to use the calculator. Nice. Awesome. Now try to repeat this for the two 60-degree triangles in the third and fourth quadrants by yourself. So we make ones down here. Right, well, if we want 60 degrees in here, we'll have to go to 180 and then go an extra 60. So 180 plus 60 would be 240. Nice. Right, now horizontal length. Oh, it looks like it's the same as this one, so just negative 0.5. Cool. And the vertical, it should be 0.87, just like these ones, but positive 0.87 would go up if we did that. Whereas we want to go down here, so we'll make it a negative 0.87. Nice, last one. Okay, this one will go across to 270 and then add on 60. That wouldn't quite work. But usually it's better to go from the x-axis. So let's go all the way around to 360 and then come back by 60. So 360 minus 60 would be 300. Nice. And then going to 300 will make it this little gap of 60 degrees in here, which is what we wanted. Okay, horizontal length, yeah, it's the same as this one. So they're all 0.5s, but these ones are negative because they go to the left. This one will just be the same as this, which is positive 0.5. And then this one is going to be 0.87, like all the rest of them, but it goes down, which is the same as over here. So yeah, it should be negative 0.87. Awesome. Really awesome job. You may have noticed we use 0.5 and 0.87 a lot this lesson, and even in the previous ones. We use it for the 60-degree triangles we just did, but also for the 30-degree triangles early in this lesson. There's a reason for that, which we'll talk about in a later lesson. For now, Mr. Frog is all tucking out from that one. Let's give him a rest. Okay. Very nice. We've unlocked level 4. So go ahead and do the practice questions down here. This one might be a little bit confusing, so you can always use the video explanation to get an idea of what we're actually asking first, and then you can try it yourself. And then same for these ones, and then we go all the way down to question 3. Once you finish those, come up here, tick this lesson off, and move on to the next one.